Hello everyone and welcome to today's video. So in this series, that's episode 2 of Packet Engineering Experience, we are looking at HSRP. My previous video designed a script to capture spanning tree packets, watch them, and send them back into the network. Today we are looking at HSRP. I have this Kali machine over here. Kali is connected to IOU2 acting as an access switch. I have two switches over here. They are acting as my HSRP routers, switches. So they have a virtual IP, which you can find here. So this one, show IP is brief. So we see the IP over here, show standby. Then we see the virtual IP address right over here. You also see the standby router. Now let's go to the standby router. So I have show IP, interface brief, show standby. And as you can see, I have preemption on um, active router with a priority of 100. But then there's the priority of the standby is 50, but then there's no preemption. Good. So now let's ensure connectivity between the two switches. As you can see, we can ping each other. 92.1.1. So now we have full connectivity between our switches. Now back on the topology, you see my Kali machine is connecting to the access switch. So now let's go to Kali. Ensure we have connectivity, the virtual gateway. We have connectivity to the virtual gateway. Now let's try switch 1, it works. Now switch 2 works. Clear. So it's now time to analyze our Python script. So this is the script that I designed basically for HSRP. So this is a loop which is going to loop the packets all the way around. And this is the HSRP packet. Actually, it's a variable containing all these layers which can be defined in an HSRP packet, okay, or a packet destined for HSRP. So at layer 2, we have the ether. So the script will use the default ether parameters or the attributes for execution. And at layer 3, we have the IP source and destination. The IP is the current IP on my Kali machine. We will check that. Then the destination is the well-known multicast address for HSRP. That's layer 4, that is transport. We have UDP. And then we are using the well-known UDP for UDP port, destination, and source for HSRP. We will check all that. Then we have the main HSRP packet. We have a version of 0, optical state. So the state will show you the state where I got all these packet attributes from. And we have the hello time, we have the whole time, and the priority is 120. Mind you, the priority on the switch 1 was 100. Then we have a group 1, and then here I'm going to send the data we design via this interface loop and then verbose. I'm going to save it. I'm going to close it. What I'm going to do next is going to open Wireshark, show you how I designed this packet. I will open Wireshark and select my interface filter for HSRP. So I'll pause the capture, use the size, I'll select active. So this is the data link layer. That's the physical layer, sorry. And then this is the data link layer where we have the ether. So it's going to use the same default parameters. Now at layer 3 here, we have the destination, the well-known multicast of HSRP, and the source is the IP address from switch 1. We have our UDP, as you saw in my script, that's the well-known MAC address for well-known destination and source port for UDP with respect to HSRP. Here we have our HSRP main packet, the header. Sorry. So in the header, we have all these attributes of HSRP. So this is where I sniffed the packet on the network on the access layer and then designed my own packet. Now I have it's using the default password of Cisco. So that's the vulnerability over here. So you shouldn't use the default password for Cisco on HSRP routers. You have to change it to a different thing. And also this is the virtual IP address. Good. So now I'm going to close this. Don't save. So I'm going to run my script. And before I do that, I'm going to start Wireshark capture over here. I'm going to filter for HSRP. Okay. So I'll minimize it. I'm going to run my script. And as you can see, the switches are getting confused over there. So for as long as this thing will run, so I'm going to pause it because I'm using a virtual environment. I don't want the script to the lab to break. So I will just pause it. So we sent 8,901 packets to the network. And now as you can see here, you can read clearly over here that group 1 active router's virtual IP address is different. The local configured address on this, and hence the state was changed to standby. Same applies to here. It went to a listening state, it wasn't running. So once again, we can start my script and I'll leave it running so we can confirm from here. So as you can see now, the HSRP on the switches has broken down. So show standby. So as you can see, even the previous router switch, which was the gateway, the active is now on standby mode. Show standby. And as you can see, the active router is now 1.200, which happens to be my Kali machine. As you can see, the switches are confused. So if you have device on the network, they can't ping their gateway, everything will be breaking down. So it's very advisable for you to configure these protocols with authentication MD5. Okay, so this is how to design an HSRP packet to break HSRP. And if even if I was to use a different Python code, if I used for loop, the switches will just break. Switches will all go down, and then you can't fasten the doors on the network. Hello everyone. So this is a quick video, an add-on on the video I recorded earlier. I forgot to explain the packet capture as we perform the attack. So as you can see, let me scroll up. So at this point, this is where the Kali machine sent the first packet to the network, telling them that, hey, I can also form an HSRP um, alliance or form HSRP with you, and I have the highest priority. So at that point, the active gateway on which one resigned as the active gateway for that particular VLAN. Hence, this Kali machine took over, and for as long as the script was running, it was active until we stopped the script. So that was a quick one to explain what really went down when we initiated the attack on the HSRP protocol. Thank you. So thank you for watching this video. I'm really grateful, and see you in my next video where we'll dive into um, packet experience with a different network protocol. Bye bye.